this is going to be a little look into the dark art of actually writing code in practice at these low levels. It's something that is not often taught in universities, I think. Often people are expected to just kind of pick this up by being around other programmers. But I thought it would be maybe interesting and useful for you guys to see how I write code myself, in case there's any ideas you would like to nick from my setup. So I think I'll talk a little bit about command line tools, and I'm going to talk about Vi or Vim, which is my text editor. And if we have time, I'll talk a little bit about build systems, make and cmake, and a little bit about source control with Git. So these are the main tools that I use pretty much every day to do the bulk of my work in. Together they form what is known as an integrated development environment, or IDE. So an IDE is a place where all your tools are brought together. You can connect them up in various ways, make them work together. And this is done primarily through the command line. The command line forms an IDE because it's where all your tools appear, where you can link them up and build your powerful stuff. So I hope you guys can see okay on my screen. Please let me know if the resolution is not good enough or if the video is too slow or anything. This is a fairly typical development environment for me to be in today. This is my terminal. Here is my command line. I've got a couple of other windows open. In this case, I have some notes that I'm going to talk about. I've also got my comm stuff so that you can see me and I can see what you're talking about. You can see from this little dollar symbol, you can see I'm in what is known as a bash command prompt. So there are many different command prompts. Bash is one of them. They all have slightly different syntaxes. If you've got a dollar, you're in the bash one. You can also see, here is my name. That tells me who's logged into this computer. It tells me the name of the computer. This machine's called XPS because it is a Dell XPS. And I can see where I am. This little symbol means my home directory, and this means I'm in a folder called TSE. So this is a fairly natural computational environment for me to be in today. I was going to talk a bit about the physical environment as well. Before you start writing code, you need to be set up physically as well as computationally. So this is the main room in which I'm working during remotization, at least. You can see this room is fairly empty. It is deliberately free of distractions as far as possible, because when you code, you really have to focus 100% on what it is you're doing. You can see this room is very light. I'm sitting right in front of a big window here with direct sunlight shining on my head. And I care a lot about that. I can only code if I'm in very bright sunlight, real natural sunlight. So on occasions I've had this written into my contract when I take a job that I have to be in a room by a window with direct sunlight so that I can get my work done. I've got a drink here. It's very important to stay hydrated when you code, to be comfortable. Usually this is water. Today it's peppermint tea, slightly cold peppermint tea. You can see I'm not wearing a suit or a shirt because I can't code wearing a suit or a shirt. I want to be wearing nice, loose clothing to get some real work done. We'll also see about 5 minutes out of every hour, I'm going to stop doing any work and I'm going to mess around with my physical body probably by playing this guitar over here for 5 minutes, which seems to be a very important part of the coding process. You can't code constantly. Every hour you need at least 5 minutes off so that your subconscious coding brain can do its thing, and that's often when a lot of the real work is done. Your fingers are busy playing a guitar, and in the back of your mind you're actually fixing the bug that you've been trying to solve through the rest of the hour. Okay, normally I'd have some music on as well when I code, which is usually going to be electronica or really cheesy Mozart or occasionally black metal. They just seem to be the three genres of music which are most conducive to coding. You want to have music that doesn't have obviously intelligible words, because the words will get into your verbal loop in your brain and distract you from thinking about coding. So if you have music with words, ideally they should be in another language, or they should be screamed or otherwise intelligible. Many people specifically seem to like listening to Mozart when they code. There seems to be something no one understands, specifically psychological, about Mozart and coding. So that's the physical environment. Here's my computational environment, and this is my command line. This is where most of my work is going to take place. Oh, here's my keyboard as well. I've got a nice ergonomic keyboard here. I'm coding on a laptop. The laptop is lifted up so that the top of the screen is level with my eyes, just about. Oh. I'm also sitting in a Herman Miller Aeron chair, where the arms are level with the top of the desk. So when I sit like this, I've got a nice, everything is right angles in my body, okay? I'm making a right angle between my legs and my torso. If I put my arms on the arms of the chair, you can see they're level with the table, and I can come out and reach the keyboard like that. Okay, so here is the computational environment. I'm sitting here in a command line. I can type cd for change directory. Cd by itself will take me to my home directory. Let's have a look what's in my home directory today. Lots of stuff. I'm going to go into a directory called PSE. And it's got some stuff in it to show you guys today. So when I type cd and the name of the directory, that's going to do change directory to get me into that directory. I can make a directory by typing mkdir make dir. So here I've made a directory called A, ls to list the files. There's my new directory A, cda. Now I'm inside that directory. Now I can go back up. Okay. You can see I've got a bunch of files in here already. These are mostly text files. Some of them are program files. Let's do some basic file manipulation. Let's say I want to move a file. Here's a file called foo. I'm going to move it. I'm going to change its name to bar. So now the file foo has disappeared, and we have a file called bar instead. I can copy a file. Let's say cp for copy, going from foo to, oh, I just deleted foo. I moved it. I called it bar. So I'm going to copy bar, and I'm going to call it foo2. Now I have a copy of that file. I can remove a file, typing rm for remove. Sometimes you just want to create a new file with nothing in it, and you can do that with the touch command. If I do touch B, you can see that's created a new file called B. It's just an empty file. Sometimes it's useful to do that. Okay, when I list the files, I'm normally typing ls for list. Now, many of these commands have evolved over at least 50 years to be as quick and easy to use as possible. So you notice when you type ls, it's the two letters on opposite sides of a regular keyboard. You type L with one hand, S with the other. They're very quick to type. ls return. ls will normally list the files like this. You can do it in some other ways. Here I'm giving it with an option. If I do -L, it will give me some extra information. So you see, this way of listing the files tells me the dates the files were last modified. It tells me who the owner is. It tells me what are the reading and writing permissions, and it tells me how big they are. If I want to see that in a slightly more human readable format, I can do H for human as well, and you can see the sizes of the files are now put into things like kilobytes and gigabytes, which are a little more human readable. If I've forgotten how to run a command such as ls, I can always type man. Man is the manual. So if I type man and the name of a command like ls, this will take me to the man page. And this tells me everything I ever need to know. So if I want to list my files and I'm trying to look at one of those options, let's go find the L option that we just saw. Here we go, look, L for long listing format. I can quickly look things up in the manual using the man command. Okay, if I've made a directory, let's say C, I'm going to touch, let's make, say, 10 files sitting inside that directory. And now I want to get rid of this whole thing. I've got 10 files sat in a directory called C. I can also list the directory from being up here. Look, there's everything inside C without going in it. So if I type rm rfc, I'm going to be very careful before I press return, because when you do this, this is removing, it's doing it recursively with R. That means I'm removing all the files and subdirectories and sub-subdirectories and so on. And I'm also going to force them to be removed, which means the system isn't going to come back and ask me if I really mean to do this or not. So this is a dangerous command. This is going to completely remove that directory and everything in it without any obvious way of ever getting it back. So I'm going to check that very carefully. I'm going to check that I'm actually in the directory I think I'm in. I'm going to check that C is the thing I think I'm deleting, and then I'll do the command to get rid of it. If you want to get rid of all your files, you type rm rf star. Star means all the files. It expands to all the names. I'm not going to press return here because that's just going to delete everything in this folder. You can potentially delete everything on your computer by just going to the root directory and typing that command. So especially if you're going to do rm rf star, be very, very careful where you are and how you go about running it. Very dangerous command. Okay, sometimes I might want to find a file. So let's see what files we have. Okay, here's my Python directory. As it happens, there's a file called foo3 sitting in my Python directory. So if I want to find the file in any of the local subdirectories, I'm going to use the find command. So if I do this, I'm going to say find dot means starting from the current directory. If I wanted to start from the root directory, I could start like that. If I wanted to start from my home directory, I could start like that. But in this case, I want to start from where I currently am, and I want to find any files whose name is foo2. So here it's done a quick search through all the local subdirectories, and it's showing me where my file is. You can also find based on other criteria, like the file size or the modification date. Are often things you might want to look for. When you run a find, it can get quite slow if you're searching through your entire hard disk for something. So there's another command called locate. So for example, if I type locate Python, that has almost instantly given me every file on my whole system, which has the word Python as part of its name. When I did locate, this is different from find. It doesn't go searching through the directories. It does an almost instantaneous lookup in a big table. And this locate table is kept up to date. So every now and again during the day, your computer will run a little task in the background, which checks all the files on your system. It sees if anything's changed and needs updating, and then it will go and keep track in that locate table of where everything is. So sometimes, if you've only just created a file like foo2, there's already a load of foo2s. If you've only just created a file, locate might not work because the locate table might not have updated. So you might have to go back to using find. But especially if you're looking for system files like Python that just sit there forever, then locate is usually the best choice. Okay, let's talk more about that star character. When I do, say, a list command, I can give it arguments. I can say I only want to list certain files. So for example, list all the text files. Star.text expands to all the names of the text files sitting in that folder. Sometimes you want to look for hidden files. If you do ls-a, that says show me all the hidden files. So you can see there's a couple of extra things that are actually hiding in this folder, right? You see this is a swap file. This is something that's been deliberately hidden. These are links to the current directory and the directory above it. If I go to my home directory, I'll probably find a whole bunch of hidden files. There's lots of these files that all start with a dot, and they're there because I don't normally want to see them. You know, they're things like system configurations, backup files, and so on. Git information we'll talk about later. But sometimes you need to see the hidden files, especially if you're going to clear them out for ls-a. And if you want to do -a and l, or l and h and a, you can combine them together. So here's all my hidden files in long format with human readable information. Okay, let's talk a little bit about reading and writing files. You know, hello world. Everything should start with hello world. So echo is a small command which takes a string and outputs it again. That's why it's called echo. It's like shouting into a tunnel, and whatever you put in comes back to you. By itself, not hugely useful, but we can combine it. So this little arrow means send the output of a command into a file. So if I send echo hello world into my file, it no longer prints to the screen. But if I look at the contents of my file using the cat command, which will by default show me what's in the file, I now have a file called my file sitting in here somewhere. There it is. And you see the content of that file has hello world in it. So I can decide if I want the output of my command to go on the screen by default, or if I want to send it out to a file like that. If I want to send some more stuff to a file like this, I'm going to put in 2 of those arrows. That tells it to append to the file rather than overwriting the file. So you'll see if I do a cat on my file now, we've got both hello world and we've got more stuff. Okay, if I'd have done it like this, then it would overwrite the whole file like that. Notice I don't have to type these commands. I can use the up and down cursors to switch through to run historical commands again. Or I can type history. History will show me all the commands I've just given. You know, this is useful if you've been messing around and you want to remember what you did. You've got a record of all the commands you typed in. Okay, so this cat command is very powerful. It stands for concatenation, which means joining things together. So if I just do a cat of my file, I simply get my file back out. Okay, if I do a cat of test1, I get test1 back out. But I can give both of these things as arguments. I'm going to cat my file and test1 at the same time, and this is going to join the 2 files together. It's going to concatenate them. So I might want to concatenate the files and send the result of that to another file called out. So now if I inspect what's in out, I can see the whole contents of the out file. Sometimes I want to check if 2 files are the same or different. I can do that with the diff command. So let's say, what's the difference between my file and test1? Are they the same? Are they different? And this syntax is called diff. This is a diff report, or it's just a diff. This syntax means line number 1 in one file had this thing, and in the other file it had that thing. I could run that on a whole novel or a thesis and find all the places where edits have recently been made. It'll give me the line numbers straight away. Again, I might want to store the results of that diff into a file. You know, someone sent me a new copy of their PhD thesis. I do a diff, send the output to a file, and now I'm going to inspect that file, and I can see all the things that they've edited since I last read the thesis. Okay, let's play with text a little more. Let's send a list of files into a file. So here I'm taking the output of ls. I can just send it like that. Actually, I'm going to send the output of the ls command into file fn for file name. So you see that file now contains everything that would normally come out of the ls command. So what if we wanted to sort that file? Okay, I could type sort like this, and it'll sort it by default into alphabetical order with some other arguments into some other orders. I I can take the output of one command and pass it straight into another command like this. So here I'm going to run ls, and now instead of an arrow, I've got what is called a pipe. That's the little bar next to the Z key on my keyboard. So that pipe is going to take the output of this. It's going to stop it appearing on the screen, and instead it's going to send it to become the input to the sort command. And then I can take the output of sort, and in this case I do want to send it to a file rather than another command. So I'm going to use the arrow like that. So in this case, I've now created a new file called O. If I inspect O, that's got all the output of the ls, but in this case, it's been sorted. Sometimes you do want to see what's going on the screen while you're doing stuff with files. So you think of these inputs and outputs flowing like water flowing down a pipe. And one thing you do in plumbing sometimes is you make a T. You have a special plumbing pipe in the shape of a letter T. And it means water flows in one way, and some of it goes through one bit of the pipe and some goes through the other. It's making two copies of the water. So we have an equivalent T command named after that pipe. In this case, I'm going to do ls. I'm going to pipe the output of ls into the T command. And T is going to send it all to a file, in this case called out, but it's also going to print it on the screen at the same time. So you've got two streams coming out of the T. This one's ended up on standard output on the screen, and the other one will have ended up in the out.txt file, looking exactly the same. Cat can get a little bit unmanageable for very large files. So let's take this one. Sometimes the thing will just whiz past through your screen like that. So we have a little command called less. And less is a little more like a text editor. You can't change the text, but you can scroll up and down it using the cursor keys and press Q to get out. So normally small files we will look at using cat, large files we will look at using less. Less is very cleverly written. Even if your file is many gigabytes long, less is usually able to deal with it. It's very clever in that it only loads the parts of the file that you actually need to look at. So sometimes someone gives you a gigabyte of data or audio or something, and it just won't load in any other program. Less is your tool of last resort if you want to go and see what's inside the thing. The find command we saw is for searching by file name. Sometimes you want to search inside files. You want to say, find me all the files that have the word English in them. And that is called grep. That stands for get regular expression, because regular expressions are used in searching for things inside files. So let's say I want to find all the files that have the word English in them, and I want to look inside all the files in the current directory. The star again expands to all the file names currently available. So you can see it's complained that some of these files are directories. Then it's actually found one particular line. So here are all the files I'm in. It's found that in that sample file, there is the word English appearing on that line. And if we had other files with the word English, we'd get reports of all of them. So grep is so widely used that programmers tend to assume it's always available, even in real life. You know, I've met programmers who've very briefly tried to grep for their keys in their house and then been annoyed that grep wasn't available. Or I've seen people try to grep paper textbooks searching for a keyword. If you want it to recurse, by the way, you put in R for recursive. That's getting rid of those errors about directories, and it's going to check all the files inside the subdirectories as you go along. Right, when your computer is very slow, usually because you're running your own code on it and something's not working, you need to know, what is my computer doing? What is it spending its CPU time on? So this is a command called top, and it's a top 10 table, if you like, or top 30 table of what is using up your computer's resources. So top is giving me this continually updated screen. You can see the numbers are changing because my computer's doing a whole bunch of different things. And by default, I think this is ranked according to how much CPU time are these tasks taking up. Every line here is a process running on your computer. Now you can see some of these processes are owned by me. They're my problem. So these may be things like the web browser I'm running, the terminal I'm running, this text editor, and so on. Other processes here are part of the operating system. They're running in the background. And so those things are owned by root. And so you can see the names. If I just expand this out, let's see what's actually taking up the most CPU resource, right? 50% of a CPU is being taken up by Chrome, as it happens, just doing this Microsoft Teams over here. Next up is Xorg. That's the Windows system. That's quite a lot. Xorg doesn't normally take that up. That's probably because I'm streaming this through Microsoft Teams, and that's putting an extra load onto the Windows system somewhere. Yeah. Then there's stuff in the operating system. You can see Pulse Audio is the sound system. There's the famous System D. There are lots of these inner operating system processes. Sometimes you'll see things just kick in for a few seconds. For example, to update the locates list of file names. Every half hour or so, locate is probably going to kick in and decide to go and update a bunch of stuff. So if your computer is sluggish and you want to find out what to kill, fire up top. Every process has an ID, process ID. If you take that number, copy it, and give something like a kill command. I'm not actually going to do this because it'll terminate the video call we're on. That's a way to clean up your system by getting rid of resource-hungry tasks. Okay, not everybody realizes that the shell is in fact a fully fledged programming environment as well as an IDE. Often we're only giving these little commands like ls, but you can actually program in Bash. It's a church complete programming language. So for example, if I type export a equals 5, that is going to set a variable called a. So for example, I can now go back and give that echo command, say print out the value of a. There I've got the value of 5 coming back. Some of these variables have special names that are conventionally used by a whole bunch of programs. So for example, path is a variable on most systems which everyone will look at to decide where to go and find other programs. So if I type the name of a game I want to play, Space Invaders, whatever, what actually happens when I press return there is that the system is going to look at that path variable. You can see it contains a whole bunch of bin for binary directories. The system's going to go and search in every one of those directories and say, is there a file called Space Invaders? And as soon as it finds one, and it'll find the first one, starting in the order of the path. And as soon as it finds one, it decides that's the program that we're actually going to run. So one thing that is very common to do is to add things to your path. If you're installing a piece of software and they ask you to add something to your path, this is what they mean. You say, we're going to update path. So we're exporting it, giving it a new value, and our new value is going to be the old path with some new stuff appended to the end of it. If I do echo path now, you'll see my path now includes this extra directory. This is one approach to breaking into other people's systems, right? If you override their path so that whenever they type ls, ls is just a command, right? All of these things are just programs, they're commands. If I do locate ls, okay, there's a whole bunch of things with LNS. Somewhere in there is the name of the actual program, ls. that is getting run when I type ls. But if you go into someone's system and overwrite their path so that it's pointing at your directory with your program, also called ls, then whenever they type ls, it will go off and run your code, which could do all kinds of bad things, potentially. Which is why we have security systems. Okay, so I'm logged in here as me. I am a user. I am only allowed to do certain things. The machine as a whole is owned by a different user, which is called root. And in some cases, root is a special person, a human sysadmin. And in other cases, root is you with your sysadmin hat on. And if you become root, you have to be aware that you're now in a much more dangerous position because, for example, you could do rm/rf star in the root of your whole computer and just delete everything in a single command if you're root. So you can change user. Su is switch user. Here I'm switching to me. I'll type in my password, and I've become me, which isn't very exciting because I was already me. But if I want to switch to root, I can type in a different password, and that temporarily turns me into the root user who's able to do anything. So often you will do this if you are installing software, right? Often you'll do a make to build your piece of software, and then after make you'll do something like make install, and this is a different command that actually copies the software you've built into the system. It puts it into a protected part of the hard disk where only root can access it, and that makes it runnable by all the other users on the system. And so only root is allowed to do that. Often commands that require root are not specifically written saying that they require root. There is a long-standing convention that if you're not smart enough to know what root is, you shouldn't be doing it. So if you ever type make install and you get some sort of error message saying you don't have permissions, you need to go and become the root user and then do make install. And they've deliberately not told you to do that because you need to know what a root user is and what it is capable of doing before anyone's going to allow you to actually have root access on one of these systems. Even on your own system, it's to protect you from yourself. How does the locate program know how to spin into action every half an hour to rebuild that table of file names? Something has to sit there checking what time it is and saying, has it been half an hour since I last did this thing? Is it time to go again? So you often want to do this. You often want to set up a program that will run every half an hour or every 10 minutes or often once a day. You want to back up all your files every night at 3 o'clock in the morning. So doing this is called a cron job. A cron stands for chronometer or timer. So let's do this command cron tab. This is the cron table with -e on the end for edit, I think. So these are all just comments. What you see here is a cron job. This line describes one cron job, and this says that at 15 minutes past 9 every day, I'm going to execute a command. Okay, so let's try setting one up. I'm going to change this. The time is currently 14:34, so let's say at 35 minutes past 2 every day, we're going to touch a file called foo4 directory. It's going to have to be 36 minutes past now. So we just hit that one. So you should see there's no file called foo4 currently sitting in here. Let's wait until we get to 14:36 and see if that works. So there's a couple of people saying the screen is frozen. Is that happening for everyone? Can anyone still see the screen? The video is 1 frame per second for me. Okay, it might just be the connection at your end if some people are working. Tell you what, I'll try stopping my screen share for a sec and then I'll do it again. That sometimes seems to work. Is that any better? Okay, so look, the time is now 14:36, and you can see when I do ls now, that file foo4 has just appeared. Okay, so that's the thing I set up in my cron table, and I said at 14:36 every day, go and run this command. And this is just a little touch command. This could be anything. Usually this is the name of your program that you want to run, to do the big backup or do the big data analysis. You can also run cron jobs at other intervals. Doesn't have to be every day. It could be every minute, every hour, or on other kinds of conditions. So there's a lot of things you can do with a command line. If you really like, you can do full-on programming like this. Here we're saying for each file name in a bunch of files. So maybe you can see we've got a bunch of files called test. We already made test 1 and test 2. Now you can say for each file name in test star, do this command. Go and rename it. And that has gone. It's found all the files that start with test and it's renamed them in bulk. Now this is useful if you've got a million files of CSV data and you want to quickly rename all of them according to a standard pattern. You can also combine things. So for example, let's say I want to take all those files that I just renamed. So I'm going to do rename test star. Let's say I want to sort them all, and I'm going to send the result of that to out. And now we'll look at out. Okay, so that's a combination of pattern matching, concatenation, piping it into sort, sending it into a file. So there was a time when a lot of code was written in Bash like this. Bash is a scripting language. You can create small files that are there as glue to run a bunch of programs and link them together. Nowadays, we don't do that as often because we have languages like Python, which play a very similar role. Before Python, there was Perl, but occasionally, in some areas, you will still come across this. You'll see big Bash scripts doing a lot of work just inside the command line. Okay, so that was a short tour around the command line. Now let's talk about editing the text itself. You notice I've not actually edited any files yet. I've just been renaming them and moving them around. So, Abraham Lincoln has this famous quote, "Give me 6 hours to chop down a tree and I'll spend the first 4 sharpening the axe." And this is just as relevant to development tools as to tree cutting tools. Every hour you invest learning to use your text editor more efficiently is going to pay you back big time over the next 20 years of your career, or however long it's going to last nowadays. So I currently use Vim as my text editor, also known as Vim. There are only 2 text editors. There is Vim and there is Emacs, and they have both been around forever, longer than probably any of our lifetimes. And they may look very old-fashioned and hard to use when you first see them, but they are actually very carefully and well designed and have evolved over, probably 50 plus years to be as efficient as possible. So if you open Vim like this, here's what you see. So because these programs have such long lineages, there are many versions of them and they have many different names. Okay, so back in the 1960s, there was a program called Ed, which was the text editor. 1969. It was extended by Charles Haley and Bill Joy in 1976 into another editor called X for extended editor. Someone added on a visual interface. So until this point, these things were line editors. You would type a command to print, and it would print out the content of your file, and then you'd type a command to edit a line, and so on. When we got to 1979, it acquired this visual interface that lets you interact with the text. And so it was called VI for Visual Interface. And then various people have extended it since then. Somebody modified it with improvements. Firstly, to create a program called Stevie, and then it became Vim for Vi Improved or Vi Modified, written by Bram Moulinar, which is just about the thing we have today. Vim originally appeared on the Commodore Amiga in 1991, but it's continued to evolve to the system you can see over here. So you can see I'm typing some fairly cryptic looking commands down the bottom to make Vim go, which I'll try and give you a little bit of insight into. So Vim and Emacs are both excellent text editors. I used to use Emacs for a long time. I'm actually quite new to Vim. So I'm not as much as an expert in Vim as many other Vim users because I've not been using it for as long. To become a real expert in any of these editors, you need to use them for 20 years. It's like learning to play a musical instrument, and they are designed along the same principles as musical instruments. So, in particular, you wouldn't play a musical instrument using a mouse. Can you imagine trying to play a piano by clicking on a little drop-down menu and then choosing play note and then choosing the volume and then choosing the pitch and then clicking on go? It would just take far too long. And mouse control is measurably low information. The amount of information you can put into a computer using a mouse is much less than it is using a keyboard, as it is with a piano. And you can measure this in the number of bits per second that a skilled programmer can flow through those interaction systems. So also like a musical instrument, you have to practice. You're not going to get these nice popping up menus and things telling you what you have to do. You are expected to do the work and learn how to play it. And the reward for that is that you can then go faster without all that stuff getting in the way. So if you're new to Vim, you're going to need to spend at least a couple of days just sitting down and learning it, like you'd learn to play a piano. If you've been using it, well, for any length of time, it's still good to spend a couple of days every year going back and exploring it and having a mess around. It's always updated, always new things coming in. Yeah, Vim Tutor is your friend. Vim Tutor is a great command for absolute newcomers to come and learn some of the basics. So I'm just going to show you some of those basics in action right now. So most systems, Vi and Vim will do the same thing, right? Vi is easier to type. It means you've only got to press 2 keystrokes, but the program you're getting is actually Vim. Let's start Vi or Vim with the file. Here's a sample file that has some text in it, okay? So this freaks out newbies because when you press a key, it either doesn't do anything or it does something completely weird, and it certainly doesn't enter any text. Now, you also find instead of using the cursor keys, we use the letters H, J, K, and L, which are all the keys under your right hand. Move around. So H and L move you left and right. J takes you down. K takes you up. You've got to learn to feel the up and down in your fingers. The J finger is heavy. You feel the weight of it pushing you down, and the K finger is light like helium, and you feel it lifting you up into the sky. And you also notice the J key on your keyboard will usually have a little bump on it. That bump is there along with the one on the F key. The bump is there so you can find that part of the keyboard with your hand without having to look at it. You can just put your hand down. This finger is going to feel for that little bump, and then it's in the right place. And then we can very quickly zoom around the text like this. Okay. So Vi is what is called a modal editor. That means it exists in one of usually 3 modes, and the mode you're in makes all the keys do different things. This is different from other programs. If you're used to programs like OpenOffice or Emacs even, or Notepad, usually in those programs you give commands by holding down multiple keys. You hold down Control or you hold down Shift Control. So in Emacs, you're often holding down loads of keys at once to give fancy commands. Vim is different. It is modal, which means you only ever press one key at once, and you're going to press sequences of keys to do things. The sequences put you into different modes to give the different commands. So yeah, Vim has 3 different modes. Okay, what we're currently in is called command mode. That means all the keys on the keyboard are bound to different commands that do useful things, such as H, J, K, and L being bound to moving me around commands. So every key on the keyboard is live. You know, it's linked to a function that's going to go off and trigger, hopefully, something exciting and useful. If I actually want to type some text, I don't want to be in command mode. I want to be in insert mode. And I can get into insert mode by pressing the key I for insert. So you see this is now changed to say insert down here. And now I can type in insert mode. To get out of insert mode, you press escape. And now I'm back in command mode. To use Vim efficiently, you need to put your escape key in a different place. You need to put it on the caps lock. So before you start using Vim, you're probably going to run a program like GNOME Tweak Tools or whatever you have on your own system, and you're going to swap the keys over so that your caps lock button behaves as a second escape key, either as a second one or as a swap with the escape key, because you're going to be constantly hitting escape key with your little finger, which is usually the caps lock. Okay, let's talk more about command mode. Okay, here I'm back in command mode. Vim command mode is a language, like a natural human language. And like a human language, it has verbs, modifiers, and nouns. You know, in English, you say, you know, pass the red ball, and the ball is the noun, and the passing is the verb, and the red is a modifier. So verbs in Vim are things you can do. So for example, D is the verb for delete. C is for change. Y is for yank, which means copy. V is for visual select. Nouns are things like words and letters and paragraphs and sentences. They're all the different objects that exist in your file. So to give a command, in general, you type verb modifier noun. For example, if I want to delete 3 words, okay, I'm going to go here and I'm going to type delete 3 words. I'm going to type the letter D, I'm going to type the number 3 and the letter W, right? Delete 3 words. You see? I say delete 3 words, bang, they're gone. Okay, let's try another one. Let's try change 2 words. If I type change 2 words, you see those words have gone, and it dropped me straight into insert mode so that I'm ready to make the replacement for those 2 words. Okay, you know, I can yank 2 words, Y to W. Yeah, that means copy, so then I can paste them with the P command. Doesn't have to be words, you know. I can delete 2 sentences. So the symbol for sentence is a bracket. Am I freezing up again? Okay, I'll try resetting the screen share. One moment. Okay, is that any better? Cool. So let's try delete 2 sentences, right? That was 3 key presses, and it knows what a sentence is because a sentence ends in a full stop in this case. You know, or do I want to delete a paragraph? If there's only one, you don't have to press the number. You just say delete paragraph. Okay, let's delete this paragraph. Okay, undo. Letter U for undo. So everything you say to Vim has this structure. It goes verb, modifier, noun. What do you want to do? How do you want to do it? What do you want to do it to? some of the other modifier, if you have things like quotation marks, there's a difference between deleting the stuff inside the quotation marks and deleting the stuff including the quotation marks. So if you do delete inside quotation marks, that's what you get. Or if you do delete around quotation marks, that's what you get. And for programmers, this is very useful because you're going to be doing this hundreds of times every day, and every little millisecond you shave off is going to seriously add up over time. So some of the other nouns you can give are things like the start of the paragraph. So that's the up caret symbol above the number 6. You can go to the end of a line with the dollar symbol, and all of these things exist as part of that language, right? So if I want to say delete until the end of the line, I press delete $. That means delete to end of line. So wherever I currently was, you see the deletion has happened from there up to the end of the line. I can say delete to the beginning of the line, delete caret, and will take me there. So if you only type a noun by itself, there's a special case. It assumes that the command you use the most often is move. So instead of typing move forward a word, move backward a word, you just type word. So if I press W for word, that's moving me around one word at a time. Right? If I press sentence, that will move me around one sentence at a time. See, it's taking me from full stop to full stop. If I press paragraph, it moves me one paragraph at a time. So those move commands are a special case of this more general verb modify noun. If I said delete 3 paragraphs, if I had 3 paragraphs, that would delete 3 paragraphs. If I just type 3 paragraphs, that will move me by 3 paragraphs. If I just type paragraph, then it moves me by a single paragraph. It's the default. Another good verb is visual select. Okay, if I want to select one paragraph, I type V for visual select. So I did 2 key presses. I type visual select and then I type paragraph, and that selects the paragraph. Okay, if I want to select 2 paragraphs, it's V2 paragraphs. That selects 2 paragraphs. For example, at that point, I can yank it. That makes a copy, and then I can paste it. And I've yanked 2 paragraphs and pasted them back in again. So the point of Vim is to reduce the number of keystrokes that you have to press to do everything in the most efficient way. And there are competitions to do this called Vim Golf, where they give you a task and you've got to come up with the shortest number of key presses to do it in the most efficient way. So, for example, you're not going to sit here pressing L, 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 L to move around the text, because that's too many key presses. One way to do this would be to say 8L. That's going to move 8 spaces, 8 characters at a time. A better way to do it is to jump by a word at a time. I'm typing www or BBB to move backwards. Or you could move one sentence at a time by typing the sentence button. Or you can move around one paragraph at a time. When you're doing code, sentences and paragraphs take on meanings relevant to the language. So a sentence is usually something with a semicolon at the end, or a line break, and a paragraph is usually something inside of a curly bracket. The other thing you're supposed to do with Vim is make lots of small edits. Okay, so if we want to edit a couple of words, the idea is you don't just go into edit mode and do them all. You treat each edit as a thing, as an individual thing. So let's say I want to change this word run. Okay, I'm going to go there, I'm going to type change word, CW, and change it to execute. When I finish that edit, I'm going to come out of insert mode by pressing escape. Now I'm in command mode, I'm moving around as fast as I can. Now I've got here, I'm going to make another edit, change word, musical notes, escape to come out. Each edit is supposed to be an atomic unit. It's a single thing that you've changed. And it's important, for example, if you do undos, each of those edits is a single thing in the undo history. If you try to do them together, they both come up as a single edit. If you want to go really fast, some people move all the keys around on their keyboard to make what is called a Dvorak layout. That puts all the vowels on one hand and the common consonants on the other hand, and then you can go really fast. Great for typing English, at least. This can mess up your nice thing with the HJKL, but it's relatively easy just to swap the keys back in Vim so that you still have the 4 cursors on your right hand. But now they're sitting on the Dvorak consonants instead of QWERTY layout. The QWERTY layout is ridiculously inefficient and was designed primarily so that typewriter sales reps could show off to customers by typing out the word typewriter using all the characters on the top line. And there was no intention of making it ergonomic in any way. And Dvorak is a much better thought out keyboard layout. Another thing some people like to do is put the escape pedal on their feet. Some people will get a USB pedal so that they can tap it with their foot for escape and then focus their fingers only on the keyboard. Okay, so another thing you can do is repeat commands using the full stop. So if I type word, 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 I'm moving around by words. If I carry on pressing, if I'm in command mode, if I carry on pressing the dot key, that's going to run the previous command. Yeah, let's just try that again. Let's visually select the word. I'm going to yank it. I'm going to paste it, and now I want to paste it again. Okay, so the thing I just did, pasting, is now sitting on the dot key. So whatever I just did, I can run again. And sometimes the things you've just done are going to be very complex. So for example, you can drop into edit mode and do an edit, changing the format of a data field or something, and then you can run that entire edit again by pressing the full stop. Sometimes you've got a CSV file and you want to go through every line and do the same little edit to every line, and you can just do it once and then hold down the dot key to go and do that. Yeah, U for undo. Again, that's why it's important to have these small edits so they each exist in the undo history. Control R for redo if you want to go back again. Some special commands. GG goes to the beginning. Big G goes to the end. Nobody knows why, they just do. If your document has got big, let's make this document big. So I'm going to visually select all the paragraphs, yank them, paste them, so that now the document's really big. You can do Control F to go forwards and go through it, and Control B to scroll backwards through it, like that. And then GG to go to the start, big G to go to the end. Vim has some auto-completion. So let's say we've started typing a word. I'm going to press Control N, and I get a bunch of suggestions for how I might want to complete the word. And by default, those suggestions come from a clever algorithm that analyzes the text you're currently writing. In other setups, these will come from the language you're using to give you elements of a class, functions and members of classes typically. We can do searching. If I type a slash, let's go and look for the expression key slash key. This will take me to every instance of key, K-E-Y, and I press N for next to scroll through. You can also do searches with regexes. This is more powerful than some other editors. You can do K star Y. That'll find everything with the letters K followed by anything followed by Y. So that includes the keys, but also a bunch of other things. You can make very complex patterns to be matched using regexes. You might want to do search and replace. So let's select a bunch of stuff. Within that selection, I'm going to type colon search, S for search. Let's replace the word keyboard with guitar, and let's do it globally. You see everywhere that it said keyboard has now changed to guitar in a search and replace command. Why did I type the colon on there? So I mentioned Vim has 3 modes, okay? Command mode for moving around, insert mode for writing text. That was an example of the 3rd mode, which is called X mode. And you remember X is one of these historical editors that Vim evolved out of. So X mode gives you this little command line sitting down here. So that search command was something I typed as an X command. There are lots of other commands you can get from here. So for example, :W, that's an X command to write the file. Okay, that's saving it, called write in Vim. I can do :Q to quit, usually :Q exclamation mark to really quit. Or I can do :X, which will save and quit at the same time. That's usually what you do. Often you're going to use Vim because you've got a little file like this one. You want to come in, make a little tiny edit, and then do :X to save it and get out, all running very smoothly. You can also give colon and a line number. If I do :5, that'll take me to line 5. Right? So this is useful. If I was out here and I just got an error saying syntax error at line 5, I'm going to go into Vim and I'm going to type :5, and that will take me straight to where I just got told the error was. You can run command line stuff here as well if you put in an exclamation mark. So if I do exclamation mark ls, there I'm running a bash command ls, but I'm running it from inside of Vim. If any of you are following along with Vim, most computers will have it installed somewhere. Please do follow along. I've also posted a link to all my notes on this stuff, also with notes on other software creation topics like refactoring design patterns. If it's going too fast to follow along, then please have a go from that document in your own time later on. Okay, back to Vim. What does Vim mean, by the way? It means something like sprightly or energetic. Putting some Vim into something. You might put Vim into a meal by adding extra chili flakes or something. Or if you want someone to get going, get some Vim in there. Okay. What we've seen so far is everything you need for most basic text editing. You can get all that in your fingers in a couple of days, like a musical instrument. I'm going to show you some more intermediate concepts. These are not usually things that I use every day because I don't need to, but they're things that for particular projects tend to be useful. So let's say we're editing some code now. Here's some Python code. You notice we have syntax highlighting coming on automatically in this case. Let's say you want to see line numbers. Okay, you're going to be following someone's instructions. They say go to line 27. So we'll type in set number. Now set is a Vim command to set a variable. It's a bit like export when you're on the command line. And number is a special variable that tells Vim that we'd like to see some line numbers. Okay. If we want to have no numbers, we'll say set no number to make them go away again. If you like auto indentation, you can do set auto indent. So now if I type return at the end of that Python line, you can see my cursor has come to the correct place because it understands the syntax of Python. It knows that if there's a colon there, I'm going to go in by one indentation, and it gives it to me automatically. Some people like that, other people find it annoying, and so they turn it off. So code folding is another thing that some people like. If I do set fold method equals indent, this is one particular style of code folding, which is very nice for Python in particular, because Python is all based on the indentations. So what you see now is that all my code has been folded up. Class cat is now collapsed into what is called a fold. And if I go there and hit the space bar, I can progressively unfold different parts of the code. Okay. If I want to fold everything, I'll do ZM. If I want to unfold everything, ZR. If I want to close a particular fold, ZC. If I want to open it, ZO. Each command has Z because the letter Z is meant to look like a piece of paper being folded over. It's a visual mnemonic. Yeah? So fold close if I want to hide all that stuff away. Fold open or spacebar if I want to open it out again. So other languages have different types of structure. You know, in Python, indentation is how we show structure. Other languages use curly brackets or other things. You know, HTML tags. There are ways to set up folding for all of those different kinds of structures. So you don't want to have to mess about typing all that stuff. You don't want to have to type set number every time you open a file if you're the sort of person who dislikes numbers. You want that to happen automatically. So instead of typing commands out every time, we have a special file called a .vimrc. You remember files with a dot are hidden files, so they're only going to appear if I do ls-a. Because they're deliberately hidden so they don't get in the way of everything else. So this lives in my home directory. That's the folder, and it's a hidden file. And RC, I think, stands for resource configuration file, or possibly run commands, depending on who you believe. It's actually lost in the midst of history now. Anyway, RC files are used by many programs to configure their resources. So here is my .vimrc file. You can see there's a bunch of stuff that I like they're just commands that I could have typed straight into Vim, but I want them to happen every time I load Vim up. So I've turned on syntax highlighting in particular. You know, if you don't like syntax highlighting, you can't always have syntax highlighting because if you work in robotics, for example, you're often remote accessing a little tiny computer that lives on board a robot, and you're going to have very limited resources when you run by on a little robot. So you might not want to have these flashy things in some cases. So look, I like auto indent, so I turn that on. I don't like using spaces instead of tabs, but I am being made to by a number of people, so I have to do that, and I put that in my .vimrc, so this automatically converts all my tab characters into spaces for me and defines the tab character as being 4 spaces wide. And this thing I'll talk about later if I have time. But some people will make very complex vimrc files and customize it to fit them. Other people prefer to use Vim out of the box. Now with Emacs, everybody customizes it. Everyone has a different setup for Emacs. They have all their own key bindings. And it's supposed to fit you, like a musical instrument, learns to fit to your body eventually. Whereas Vim, it is more common for people to use it out of the box. And in particular, Vim users like the fact that they can pick up another machine, such as the little machine on a robot, and just run Vim on it without having to do all that changing. But Emacs is more set up as a monolithic development environment that is customized to you. Vim is a bit more kind of lean and mean and standardized in that respect. The Emacs also requires you to do these complex multi-key presses. So Vim is all about typing fast sequences of commands. Emacs is all about multi-key presses. The reason I left Emacs is that it was hurting my hands because you have to stretch your fingers a lot for some of these keys. Sometimes you're holding down 4 keys at once. And, I've met a couple of people who seriously injured their hands using Emacs to the extent that they can no longer type and therefore can no longer work in computing, which is a career disaster. So that's why I moved from Emacs to Vim. But many people like it. Many people don't have those problems, and you pick the one that you like the best. Vim is a drum. Emacs is a saxophone. Hell yeah! Beautiful. Right. So that's the Vim RC file. Let's look at some more flashy stuff. Such as multiple registers. Okay, So normally when you yank a word and you paste it, that's the word you've yanked, that's the word you paste, and you've forgotten about anything else that you might have previously yanked. Now, what if you want to keep track of many words? If you want to cut out 4 words, like you do with scissors in a newspaper, and paste them all in different places. So Vim has multiple registers where you can yank things too. And we do that using this quotation symbol, and you pronounce that as using register. So if I want to say using register A, delete a word. Okay, I've deleted that word and it's gone into register A. And so if I go down here now and I type using register A, paste, then it's going to come back. Okay, but I can also do using register B, delete word. I can go down here and I can say using register B, paste. But if I want to use register A and paste, the content of register A would still there. So again, this is useful, especially if you're going through files of data and you want to pull a load of pieces out and stick them back together again somewhere else. You can similarly define markers in the text. Markers are just places like bookmarks that you might want to go to. If I go up here and type MA to define a marker, and then I'm going to type backtick A, that's going to take me to marker A. And I could define several markers A, B, and C. And if I want to jump around in my code to keep editing 3 different functions, say, that gives me a really fast way to move from one place to another. Okay, look. Colon Q exclamation mark to quit. The exclamation mark means really quit, and don't ask. It's a bit like the F when you do RF star. It means I really mean it. Okay, so then we have macros, and a macro is a sequence of Vim commands that you are going to record and then play back. Okay, so let's say, again, this is often done with things like CSV files. Let's say I want to do something like this. I want to skip over 3 words and delete a word, and skip a word and delete a word. And I want to do that a whole bunch of times. So I'm going to press Q to start recording a macro. I'm going to record macro A, Q A. Now I'm going to do some stuff. I'm going to go word, 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 delete 3 words, word, word, delete 2 words. Okay, that's the end of what I want to do. I press Q again to stop recording the macro. That is now sitting in macro A. So if I type at A, that will replay the macro. So that sequence of keystrokes, of the commands triggered by the keystrokes, has been recorded, and I'm running the same sequence of edits on every line here. Now remember, you've got this dot command. If you press the full stop, that triggers the thing we just did. And so that's going to rerun the macro. I can very quickly just nip through every paragraph and do that same edit in every place. Or if you're in a CSV file, you can just hold down the dot and it will make the same edit to every line. So often it's quicker to do that in a CSV file than it is to write a Python program to try and do it automatically. Vim is usually used inside one big window like this. Other editors, you tend to have lots of files open at once. The normal workflow in Vim is you go into Vim to edit one file, and then you leave, and then you open another file. You're constantly going back to the command line, and then you go back into Vim to come and do something in that file. You quit that one, now we'll go and edit another one. Let's go and edit the bar file. This is bar, and so on. Some people like to have multiple windows open in Vim and use it more like people would typically use those other editors. If you like to do that, you can. All these commands start with Control W for window. That's a rare Vim occasion of having to pull down 2 keys at once, as it happens, because they were running out of other key combination. So if I do window split, that's Control W S, you can see I've now got 2 windows, okay? And this window, I can edit a different file. Let's open my sample text file sitting down there. I can jump between the windows with Control W, Control W. You just double tap it, okay? You can close a window Control WC, you can open a new window, you can change the sizes of the windows, you can list the windows, if you like that style of working. It's not how I normally use Vim, but some people seem to like it. Okay, let's take a look at some hex editing. Let's talk about hex. Okay, here I've just made a little executable file called main. What's this actually doing? It's just a little test function that prints hello or something. But let's go and take a look at the executable file. Yeah, this is the machine code file that has been generated by the compiler. And when you look at these, this is Vim's best attempt to display it in ASCII. You will see some of the bytes in this file do correspond to ASCII characters, usually because they are file names or function names. But you might want to view this in a hex editor. Now we have an external program called XXD, is a hex editor. And in fact, you can run XXD just by itself like this. You can do XXD main, and that just displays the content of that file in hex format. Okay, here's the ASCII version on the right. Here's the hex codes. Here's the addresses. If you want to actually edit stuff, you can run that program from within Vim. So if you type :% exclamation mark, remember exclamation mark means go outside and run an external program. The percentage means link it to the current buffer. So if I run XXD like this, I've now turned Vim into an operational hex editor. So I can move around and actually do stuff in the hex file. This is how we used to bust into BBC micro games back in the day. You could open these for Space Invaders or Asteroids. You'd go through here. You'd normally find a bunch of either basic code or bits of assembler that you recognize, and you're going to try and find how many lives have you got, and you're going to turn it from 3 to 99 to give you a cheat inside your hex editor. Okay, we can do spelling. Let's go back to some English text. So I'm just going to turn on Vim spell checking. There you go, set spell. That gives me automatic highlighting. We can move from one error to another. If I type Z equals, I can choose which of these things do I want to correct. So here I want to pick number 29. I want to turn that word into Vim. So all the stuff you'd expect from a regular spell checker system. Okay, there are a few standard shortcuts beyond that most Vim users are going to learn. When you switch into insert mode, I've said you do it by pressing I. That's the normal way to get into insert mode. You do this so often that there are a bunch of extra commands to make it go a little bit faster. So you can choose if you want to start your insert on the current character or after the current character. If I press A, it will open the insertion after the character I was currently on. Okay, so look, I'm sitting on this R. If I type I, then it goes here. If I type A, then it goes here. What's insert after? Other things you often do is open a line. You press O to open a new line. Again, there's a variant of that using a capital O, which will open a new line after the current line rather than before it. Sometimes you want to go in and instead of changing a whole word, you just want to change one character. So I want to turn this A into an E. You can do that with replace. So I just hit R-E. That's replaced the character with another character. It took me into edit mode and automatically brought me out again. Other things you often do, there are these doubling up. There's a convention if you hit a button twice, it will do it for a line. So remember D, normally I'll type D3W to delete 3 words. If I want to delete the whole line, there's a convention that tapping the character twice gives the noun for line. So DD is going to delete that whole line. And this is something it's put in there because it's so common in programming that you want to delete a line. or you can do CC to change a line. That will take you into insert mode. Or you can do YY to yank a line, and then you're able to paste it again. So there are many of these little commands that people learn to do very specific things. In my opinion, it's much more important to learn the underlying principle of Vim first. Yeah, the underlying principle is that there are verbs and modifiers and nouns, and the language is then compositional, because every time you learn a new verb, you can apply it to all the nouns, and whenever you learn a new noun, you can apply it to all the verbs. So it's very like learning Esperanto. You get this feeling that you learn one extra little verb, and it gives you masses of power because it's compatible with everything else, And when you pick up a new language, usually someone has gone and defined the Vim setup for that language, and it will come with a load of new nouns. So if you're moving to functional programming doesn't have classes and lines in the same way, but it has a different structure based on the brackets and the function calls. And someone's going to go and define a set of Vim nouns for Haskell that will then let you use all the verbs you already know. You want to delete stuff, you want to change stuff, you want to yank it, but you can run it on the verbs, on the nouns coming from whatever kind of text it is that you happen to be editing. Let's take a very quick look at advanced Vim. Everything we've seen so far works out of the box. That's a standard Vim setup. So when you go to really fancy stuff, we're now going to add plugins. These are third-party pieces of code. Other people have written them. Vim is completely extensible. You can program it in its own scripting language, which is the same language we've been typing all these commands in. Nowadays, you can also program it quite nicely in Python, if that's what you prefer. So you'll find many people are writing these plugins, usually because they've seen something that another text editor can do, and they wish they could have it in Vim, and so they put it into Vim. So if there's anything you ever see another text editor is able to do, and you think Vim can't do it, you type it into Google. You do Vim plus the thing that you want to do, and you will almost certainly find that someone has written a plugin to do this. Vim can't do syntax highlighting. Just go and get the plugin, and it'll make it do that. If you really can't find a plugin, now you have found your calling. Here is what you can write and contribute back to the open source community to get your own code out there. But it doesn't happen as often as you think it's going to happen, because normally someone's already thought of it and built it. I'm just going to reset my screen share because someone's complaining again about the screen share being laggy. Resetting it seems to make it better. Is that better for you, Connor? Okay, so some people go totally overboard with Vim plugins, and they'll pimp their Vim into something that looks like one of these bloated graphical IDEs that we were trying to avoid in the first place by using Vim. If you really want all the bells and whistles, then you can put them in. Some people find them useful, some people find them annoying. Here's a full setup with auto completion and file browsing and automated documentation and automated debugging, all of these things. But usually the ideal of Vim is that you keep it lightweight, because your real IDE is the command line. If you're going to do debugging, you can run GDB or a graphical debugger or whatever here from the command line, and Vim is only supposed to be a text editor. So you go into Vim when you're editing text, and you go into other things when you want to do other things. Emacs is different. Emacs is an operating system which tries to do all of this stuff inside of Emacs. It is sometimes said Emacs is a great operating system. It just lacks a good text editor like Vim. So Vim, lean and mean. Emacs, monolithic. But let's just take a quick look at a couple of these plugins to see what can be done. This has changed a lot in the last couple of years since Vim 8. This used to be quite complicated, and now it isn't. So what you do nowadays to make a plugin, the plugin system is called pack called packages. And we just need to make a little folder called pack plugin start. So pack is the manager, plugins is going to hold all the plugins. And all the plugins that we put in the start folder are the ones that we want to load up every time Vim starts. Okay, you can put them in other places to make them optionally available, just when people ask for them. So let's say we want to download a plugin. So I'll show you this one. This is called Nerd Tree. This is a thing that does the file browser sitting in the panel on the left. Usually you found the plugin because you've been searching the internet and you found it on GitLab or GitHub. So in this case, I found the source of it on GitHub. And I'm just going to go into my plugins folder and I'm going to clone the plugin straight from Git into the plugins folder. So there it is. There's a little folder called Nerd Tree. Let's look inside. There's some stuff inside. Don't actually care about that stuff. Just hopefully it's going to just work. So now if we load Vim, that error message, by the way, is to do with swap files. It's saying there's a backup of the file that is different from the one I'm currently using. That's just appearing because I'm messing around a lot with Vim today. We can get rid of it just by deleting the backup file, the swap file. Okay, so now I'm in Vim. That plugin should have been loaded. And the plugin, in this case, has given me some new commands. So I now have this new command called Nerd Tree. And when I run that command, now I've got a navigatable set of files, and I can use this to browse around the project. So especially if you're writing something like C++ with all these header files that you have to keep whizzing around, wouldn't it be great if we had a language that was like C++ but didn't need header files or semicolons or curly brackets? Wonder what that could be. But if you have to keep switching between headers and C files all the time, this is maybe a nice way to do it. And it's running inside the Windows system, so all the commands I showed you for moving around Windows, like WW, to jump between them, they all carry over. Again, we can see that compositional structure of the thing. So let's try downloading another plugin. And let's go back in the start folder. Let's put in one called Ale. So Ale is a static analysis linting tool. So if this works, it should pick up things like Python programs and start highlighting mistakes in them automatically. So let's try and look at a little Python script like this. So you can see, in this case, Ale has loaded up automatically, and it's colored in all my mistakes in red. Okay, so I'm going to go look at this one. I can see what's it complaining about. Right here it's saying, this is just a warning. It's saying local variable age is assigned, but it's not being used. Okay, so yeah, that error should go away if I do something like, I use the variable again. So it's still there because it knows the variables. It still knows the variable's not getting used, right? It's disappeared from this one because that one's getting used, but now the second version of it is no longer getting used. As with all linters, you can set it up to complain to varying degrees. You can set these things so that pretty much every line of your code will have some sort of complaint coming up about it. They go all the way from things that will actually crash your system to stylistic issues. Python has all these semi-compulsory conventions now from PEP documents, and a lot of linters will give you a hard time if you're not doing your spaces instead of tabs and following all these kinds of corrections as well. So you don't want to have to go around typing these commands every time. You don't want to have to type nerd tree every time you want a nerd tree. So at this point, you're probably going to create a key mapping. You're probably going to go back to your .vim file. Get out of this one. All the windows open. Let's go back to my vimrc file. Okay, so now you know what this variable is doing, right? This is just turning on one of the options for ale to make it start up every time it loads. If I want to pop something like that into my vim.rc, here I'm going to take the backtick key and I'm going to map it to a command. In this case, it's one that just prints hello. So hopefully now if I press the backtick key in command mode, printing it down here, look, there you go. Okay, it's actually echoing hello command sitting down the bottom. Some people will build up their vimrc file with a whole bunch of these, and if you can install a million plugins and bind keys to fire off all these whizzy things in your plugin, and basically pretend that you're an Emacs user. Okay, so that was Vim. I'm just going to take you through a quick look at Make, I think, and cmake. I think you guys already know Git this time. So let's just have a quick look over Make and cmake. Maybe you are using these tools already, but maybe you're not quite sure how they work or what some of the details are. It's easy to use tools as a user without actually getting inside. So let's take a little look at what Make actually does. In the TSE lecture on Is Software Engineering, we talked about the difference between designing a program and building it. In the same way, there's a difference between designing a bridge and building the bridge. And Make is the tool that does the building. An engineer's job is done when they've made the blueprints, and then they phone up Alpha BT and get them to come with trucks and build the thing out of concrete. As a programmer, your work is supposedly done when you've written the program, and then you're going to type make to do the build. And make is going to sort out how to run the compiler on each of your source files and how to link them all together. And it's going to figure out which things can be left alone, which things have been changed and need to be rebuilt, which things need to be linked together again. So here's a small example of a C project. We've got a little function that prints hello world sitting in there. We've got a header file. Don't you guys just love header files? Don't you wish we had a C-like language that didn't need to have them? Here's a main function. Okay, so this C program is scattered over a whole bunch of files there. And you really don't want to have to go around typing gcc function.c and compile each of these things individually. You want to compile them all together. Make is a tool which does that for you. This is a make file. It's called makefile. Makefile is a special name, and the make program is always going to look for the make file when you run it. And in the make file, we've got instructions for how to do the build. So we're going to say, here's all the things we've got to build. First of all, we need to build function.o. That's the object file for function.c. Also pulling in stuff from function.h through the include. And here's how you do it. Here's the command to build function.o. Okay, so whenever function.o is needed to be recreated, this compiler command will run. When do we need to do that rebuild? We need to do it whenever something changes that requires a rebuild. So if anyone has changed function.c, if anyone's made any edits in that program, you're going to have to remake function.o. To build the whole program, which is called main, you need two things. First of all, you need function.o, and also you need main.c. And if you have those two things available, this is the command you use to build them, and in this case to link them and to produce the final executable called main. So this is now recursive. Okay, ultimately we want to build main. That's the thing that we actually run. But you can see main depends on function.o. So if anything has changed in function.o, then you're going to have to build main again. And we know that function.o depends on function.c. So if someone comes along and edits function.c, let's say I make a small change sitting in here, right? I've changed function.c. That means that function.o has to be rebuilt, and that in turn means that main has to be rebuilt. So in this case, we've got to rebuild everything. So the make file contains all these dependencies. It says to build X, you need Y and Z to be up to date, and then here's the command to do them. And you have a rule like that for every X, Y, and Z. So at this point, I can just type make. That will consult the make file, and it figures out all these individual compiler GCC commands and runs them in the right order to put the thing back together. Let's see what the program actually does. Not very much. That's probably because all the work's in a function, and yeah, look, the main function just returns 0. So we're not trying to impress everyone with the function. So this is roughly what the structure of a make file is going to look like. You can end up with many of these object files that you need. Usually every .cpp file is going to get turned into a .o file, an object file, and those object files are going to get linked together. But you can have files depending on other files, and they depend on other files. And you can see the project as a whole has these dependencies, they have sub-dependencies. And your make file is expressing this tree structure. It's expressing the Gantt chart for how to do the build. Yeah, so we're normally quite down on Gantt charts for the design of projects, but for the build of them, they're very useful, because in a build you really do need to know that this thing depends on these 3 other things, and you have to go and do those first before you can do this. And that's why a Gantt chart is used, not by the engineers who design the bridge, but by the construction company who does the build after the engineering's been done. And it's why it shows up in the make file to do the build after the software engineering has arguably been done. So make is still quite a low-level system. If you have hundreds of files, it's very tedious to have to type all this stuff out manually, because usually you'll just end up with a whole bunch of pairs of lines that look just like these two. You'll say one object file depends on one C file, and you're going to compile it using your C compiler. So there's still redundancy at this level. Make was, at one time, make was used manually. It was an advance on just manually compiling, but make is very old technology now, and it's almost always run automatically by something else. A make file is normally generated by some other part of the build system. But there are various ways of doing that. The one that I use is cmake. It stands for cross-platform make. Not for the C language. You can use cmake with a whole bunch of languages, not only C. So here's another project. I've just got a random little C program here. What's this doing? Computing the square root of a number. Okay. And this time I'm not going to write a make file. I'm going to make a cmake lists file. Okay. Now this is a higher level version of the make file. So a cmake file has higher level information in it. Okay, I'm saying what version of cmake am I using? What's the name of my project? In this case, very simple. I'm saying there's one executable that I want to be built, and it's going to depend on this one source file called tutorial.cpp. Now, in general, there could be 100 source files, and I'm going to say that it depends on all of them. Now, when I run cmake, so let's do this properly. To run cmake properly, you are supposed to always do out of source builds. So I'm going to make a new directory called build. I'm going to change into it. So an out of source build means you keep all the stuff generated by the compiler in a separate place from the source, so that you don't clutter up your source directory. So now I'm in a separate folder called build. So in this case, I'm going to run cmake from the directory above me where that file was. So this is cmake in action. You can see cmake is very clever. It goes off and it checks your system. It checks if your system has all the stuff that is needed to do the build. So it's saying, what C compiler do I have? What libraries are available? Where are they? How am I going to link stuff together? cmake doesn't do the build. It generates the make file automatically. So now you can see this is a much more complex make file. In fact, this is way overkill for what is basically a Hello World program. But yeah, this is going to scale now, and you have hundreds of source files. So normally you never look at the make file. That's not really human readable when it starts to get big. It's barely human readable in this state, to be honest. But now I can still run make as I did before. That runs the make file. That has done the build. There's my little tutorial script. Who knows what it's supposed to do? There you go. It's computing the square root. So let's just take a look at what a larger cmake file can actually look like in practice. Let's go for just finding a random medium-sized program. Let's find some OpenGL code, say. This is a little program that's going to draw a rotating GL cube on the screen. Let's just check it still works. We'll do a cmake there. Then we do a make that has built the executable. There we've got a spinning GL cube on the screen. So to build something like this is more complicated because we're linking in a bunch of libraries from OpenGL in this case. So here's the cmake file for this case. You can see once again the version of cmake, name of the project. This time we're saying go and check the system, see if we've got in this. Have we got OpenCV? For some reason we're using an OpenCV function as well as GL stuff. So we're saying you've got to have OpenCV here. You've got to have OpenGL. We're going to link these files together. We're going to link these libraries together. And the make file generated by that is probably pretty complicated, right? Because cmake's gone and done all the work of finding these libraries, figuring out exactly what the commands are that need to go into the make file. So that's my development environment. That is my IDE. It is based on the command line. I use Vim as the text editor. I use other tools which I trigger from the command line to do other things. Personally, I don't load everything into Vim. Some people do that. They want to turn it into an IDE all by itself. But for me, the IDE is the command line and that whole system of interacting program. You might be used to using other editors where all of this is done for you. If you might have things that are hidden behind graphical menus and so on. If you look behind those menus, look at the code for the editor, you'll probably find that it is wrapping many of these same tools. You'll probably find there's a make or something very similar to a make under there. You'll probably find there's something similar to a cmake. You'll probably find there's a linter and a hex editor and so on. In some cases you can get away without having to understand this stuff. Some careers you're just going to sit there writing Visual Basic all day, and you can happily use the graphical user interface that someone else has given to you. If you want to do anything more advanced in computer science, if you want to use new languages, new compilers, you want to use tools that don't have all that wrapping made for them yet because they're bleeding edge. If you want to work with systems like that, then you need to understand how these tools work so that you can actually get in at that level and be on the cutting edge yourself. So I hope that was useful to you. We normally teach quite high level software engineering concepts in here, but I thought I'd do something a bit different. This is the very lowest level. This is keyboards and text and characters and chairs and sunlight and bottles of water. But that's how I like my programming environment. I'd recommend you all give it a go.